Hello friends, welcome back. Today in this video for the subject fluid mechanics, in unit number 2 pressure and fluid statics, we are going to discuss the hydrostatic law. So, in hydrostatic law it means that the pressure variation in a static fluid. So, we are going to discuss that law and also derive an expression for hydrostatic law. Now, the law states that the rate of increase of pressure in a vertically downward direction must be equal to the specific weight of the fluid at that particular point. So, in simple words you can there is a liquid element at a particular distance h from the free liquid surface. So, the law states that the rate of increase of pressure in the vertically downward direction. So, vertically downward direction, that is h. For example, you can see in this diagram. So, this diagram basically tells you about a static fluid having a fluid element at a distance h vertically in the downward direction. Now, the law states that it must be equal to the specific weight of the liquid at that point. Okay. So, what is the specific weight of that liquid at that particular point? Point means at a distance h from the free liquid surface. So, that is the particular law. So, it means that rate of increase of pressure in the vertically downward direction must be equal to the specific weight of that element at that particular point. Now, to understand this, we have to study this free liquid element which is at a distance from the free liquid surface. This is the free liquid surface, and that element, fluid element, you can consider it is a square element having the dimensions. So, I will highlight that having the dimensions A, B, C, D. Now, the pressure acting on the liquid in the downward direction is P into cross section area. So, delta A is nothing but the cross section area of that surface, and it is at a distance h. Now, the height of the fluid element is delta h, right. Now, the opposing pressure acting at this particular point is P, here you can see P into delta h. Now, see that delta h is nothing but the height of this fluid element. So, definitely this difference in pressure will be there, and the partial derivative of P upon dH. Partial derivative, why it is a partial derivative? Because pressure is acting with respect to this height of the fluid element. Okay. And if you integrate that, we will get the actual pressure at that particular point. That is the what the law says, multiplied by the cross section area at that side or face, you can say. Okay. So, that is the face AD. Okay. Now, the next force acting is the weight. Weight also acts in the downward direction. So, weight is nothing but what? Weight density multiplied by the volume. So, weight density we denote by W multiplied by the volume. So, how to calculate volume? Volume is nothing but delta A. So, that is the area multiplied by the height. So, that will give you the volume. So, W into delta H into delta A will give you the volume multiplied by W. So, that W weight is acting in the downward direction. So, these are all the forces acting on a fluid element when it is at a distance h, suppose from the free liquid surface. Okay. Now, let us resolve the forces. Now, you can see the first pressure force acting on this face, that is BC. It is P into delta A, P into delta A. Similarly, the pressure force acting on the face AD. Now, the force acting on pressure face AD is, as we have discussed, that is P into partial derivative of P with respect to H into delta H. Now, see, this delta H is nothing but the height of the fluid element, okay, multiplied by the cross section area. So, the cross section area of that face is delta A. So, as this is a square element, the area will not change for this face and this face, okay. So, that will be similar. Now, what else force is acting? The next force acting is your weight, as we have discussed. So, that weight is acting in the downward direction, weight is acting in the downward direction. So, that weight is nothing but the weight density multiplied by the volume. So, what is weight density denoted by? Small w, volume is delta A, as we have seen. Delta A is the, sorry, not delta A, delta A is the cross section area and delta H is the height. So, area into height will give you the volume. So, delta A into delta H. So, that comes out to be volume. Okay. So, these are all the forces acting in the on the fluid element. Now, two more forces are acting. So, the force acting on the side CD and the force acting on side AB are neutralizing each other. So, those forces are same. So, we are not going to consider those forces. So, as it is mentioned here, pressure forces on the surface AB and CD are equal and opposite, and it cancels each other, okay, as I told you. So, for equilibrium condition, for a fluid element ABCD, pressure acting in the downward direction, the resultant or opposing pressure acting on the face AD and the self weight acting in the downward direction. So, that things we have to consider in equilibrium condition. Now, P into delta A. So, that is the force acting in the downward direction, and the force acting in the upward direction is P plus delta P upon delta H, delta P upon delta H multiplied by delta H into delta A. So, which is opposing pressure, opposite of this face BC. Now, as it is in the upward direction, we are taking the sign convention as negative, okay, and the self weight acting in the downward direction, adding that, right. So, when you simplify all these things, you can just simplify this P into delta A minus P into delta A minus delta P upon delta H, delta H, delta E. So, just we are doing the simple multiplication into W delta A delta H is equal to 0. So, now these two terms will get cancelled, it will get cancelled, it will get cancelled. So, minus delta P upon delta H delta A plus W delta A delta H is equal to 0. Now, shifting this term to RHS, what we get? We again can cancel these terms, delta A part will get cancelled. So, delta A, so delta A will get cancelled, again delta H will also get cancelled. So, what remains here? So, again I will repeat, delta H cancelled, delta A cancelled. So, what remains? Delta P upon delta H is equal to W, that is the weight density, and that weight density, okay. So, weight density, as we have seen in the fundamental properties, it is given by density multiplied by the specific gravity. So, in the first unit we have seen the, as per the definition of weight density, density, that is mass density multiplied by gravitational constant G, so that will give you the weight density. So, delta P upon delta H is equal to W is equal to what we say rho G. Now, doing the adjustment and integrating, because as our aim is to find out the value of P, we have to integrate it. Okay. So, P rho G H. So, integral delta delta H is H. Okay. So, what you get is P is equal to rho G H or P is equal to W into H, this expression. Or if you want to find the height, if you know the pressure, so how you can find it out? H is equal to P upon rho G or P upon W. So, this is the equation for the hydrostatic law. Okay. So, the above equation states that the rate of increase of pressure in the vertical direction is equal to the weight density of fluid at that particular point, and which is the hydrostatic law. These are the references. Thank you friends, thank you very much.